plus A. So this law, what is law of indices first of all? So before going to these laws, let us understand. If I have a number say A, if I write this A square, what is the meaning of this? This means that this A is multiplied by itself. Similarly, what is, so this A is multiplied by how much? This is so if I say A to the power n, if I raise it, then it means that A is multiplied n times. That means what? This A square, A cube, these are the notations of the multiplication of A with itself. How many times? This particular A is called the base, and the power here, this is called index or power. So with this basic idea, what is this? So let us see what are the laws of indices. This says that if A is raised to the power m is multiplied with another A raised to the power n, then this is A to the power m plus n. It is very simple. Let's see from this example to make it more clear. Suppose my m is 3 here, suppose my m is 3, my n is 2. So it says that A3 into an, sorry, not n is 2 here. What is this? A3, that means A into A 3 times. Okay, again for this A square into A 2 times. So together this, what can I write? So how many A's are there? 1, 2, 3, 4, 5. So A is multiplied by itself 5 times. So I can write this as A power 5. This 5 I can write A to the power 3 plus 2. So the first law is this. See, A to the power 3 into A to the power 2. So A to the power 3 plus 2. That means if I multiply the A to the power m and A to the power n, then their power gets added. Similarly, A to the power m, if I divide, this is division, divide by A to the power n, then this will be subtracted. Which one is getting subtracted? The denominator is subtracted from the numerator. Same example, we check here. Suppose my m is 3, my n is 2. So according to this will be A to the power 3 divided by A to the power 2. So this one I can write A to the power 3 in fraction form, division. This is what? A into A 3 times. 3 times A into A. So this A gets cancelled, this A gets cancelled. So we are left with only one A, that is only A. Okay. So if we don't have anything in the power, then we will assume this as this one. And what is this one? I can write as A to the power 3 minus 2, which is nothing but our second law. See here. the power in the numerator is the power in the denominator is subtracted from the numerator. 3 minus 2 1. Next, a to the power m. Again, if I take the power with n, then the power gets product. Obviously, from here, this is very obvious. This is no need to check. It's saying that what will happen to this. So this is a into okay. This will be this 2 times. This is a 2 times I have done. So this is 1, 2, 3 for the first part. 3 times done. For the second, a into a into a. So how many a's are there? 1, 2, 3, 4, 5, 6. So I can write this a to the power 6. There is nothing but 1. A 3 into 2. Third row. This is now this one is very important. We should always remember that any base raised to the power 0 will be equal to 1. So another one, you see, if the power is negative, then the whole thing comes down. Means, for example, if I take say a to the power minus 2, then this will be 1 by a square. Okay, so this a is called the base, and this m and n are called the exponentials, and this m and this are natural numbers. Next, to understand the concept, let us see one easy problem. So here a square b cube, this is given. Now here we need to know one thing, is that if I have root of some number, then square root is nothing but a raised to the power half. This is very important. Okay. With this idea, what will this become? This will become a square b cube for half, and one more power is there outside, that is 6. Okay. Then from the third law of indices, what we can say? A number has one power, it has taken another power, then the powers will be get product. So this will be a square b cube, this will be 3. Okay. Next, so what will be this? This will be a. If I have situation of this type, then I can write this as a2 here and b3 this. Again, by the law of indices, we can write this as a6 b9. So this is the answer. Okay. So in this way we can do lots of problem. There are lots of examples. We can go through this from the exercise. Now let us do one interesting problem from the exercise. So question is, if x to the power 1 by 3 plus y to the power 1 by 3 plus z to the power 1 by 3 is 0 is given, then you show that x plus y plus z whole cube equal to 27 x y z. So to start this problem, first let us write what is given. We have given x cube plus y 1 by 3 cube plus z equal to 0. Okay. So from here, if I directly take the cube of this, things will be very difficult. But if I reduce it to 2 terms, that means if I keep 2 variables on the left side and take one on the right hand side, then if I take cube, then a plus b cube formula I can apply here. what I'm saying, if I take the cube of this, so in the next line, okay, let me write here x plus y whole cube. What I have done, I have taken cubing both sides. Okay, this we can do. We can cube both sides. We can now. This is what if I consider this to be my a, this to my b, this is a plus b whole cube. So let us break this. What will be this? This will be x 1 by 3 to the power 3. So this will be by the third law of indices again. The powers gets multiplied. So this will be, let me shorten one step. So this will be into 3. So this 3 and this 3 gets cancelled. So this will be only what, x to the power 1. So I can write this directly, that this is x to the power 1 plus 3 a square b, that means 3 1 by 3 a square, this is my b. I am breaking into a plus b whole cube formula, 3ab square. So my a here is 1 by 3x square, if I do 2 by 3, okay, plus last will become y to the power 1, and this right hand side, okay, this will be negative of cube, this will be minus z to the power 1. Why this is minus? Because if you take the cube of a negative term, the result is negative. In place of cube, if it is even number like 2, 4, 6, then this negative will be positive. If this is odd number like 3, in case here this is odd number, so this is negative. So continuing this, let us come here. So what do I get? So we can do one thing here, you see. After going through this much, we have seen that I have got x, I have got y, I have got z. This to the power 1 I can write without power. I can write without power. Power 1 I can remove. So I have x, y, z is there. So let us do one thing. Let us bring x, y, z in one side. So let us bring x, y, z. I have shifted this z to the left hand side. And let us bring this 2 to the right hand side. So this will be negative of 3, and this if I take here 1 by 3, if I take 1 by 3 common, then this I will get x okay x plus y, okay. So if I take the cube of x plus y, this is okay 1 by 3, this minus, so this if I take the cube, so it will be this thing. If I take x 1 by 3, y 1 by 3 common, then this should be 1 by 3. So Now it will come. Now this, okay, let us take cube later on. This one I can replace from here, minus 3x 1 by 3 y 1 by 3 z 1 by 3. Now if I take the cube on both sides, then this will be x plus y plus z cube equal to minus 27 xy z. Okay, this should be minus negative here, so this will be become plus, so this will be automatically plus. Okay, so this is one problem. Let us take another problem from the exercise. So I hope this is clear. Next one is very simple, how to solve y z. So this is a very short one. This is from your exercise number 21, solve. Okay, so question is, let me do the second one. The first one is too straightforward. Second one is 5 to the power x by 5 to the power y equal to 25. 4 to the power y 2 to the power x equal to 2. Okay, so what is the meaning of solve? Solve means we have to find the value of x and y. So solution, from here, if I use the second law of indices, this is the base are same, 5 is same, so this will become, from the first one, this is 5 to the power x minus y equal to 25. Okay, from the second one we can write, from here it seems that this is 4, this is 2. How can we use the log indices? This 2 is nothing but what? 2 is nothing but 2 square. So this 4 is nothing but 2 square. So this 4 I can write 2 to the power 2 y by 2x. Now I can apply the log indices. So this will be 2 to the power 2y minus x equal to 2. This 25 also I can write as 5 square. Okay. So in law of indices we can say that if the base are same, the powers are same. So you can write x minus y equal to 2. From here you can write 2y minus x equal to 2. Okay. Now we have to solve this. So from here we get x equal to y plus 2. Okay. Now put this value here, x. So 2y minus y minus 2. I am using the value of x here. So this is 2. So 2y minus y is simply y. And this is 4. Now put the value of y here. So this will be x equal to 4 plus 2 equal to 6. So this is the solution of this equation. X equal to 6 and y equal to 4. So let us do some more problems. So this is exercise number 14 from your book. So here, if three things are given, then we have to show that with the help of these three conditions. So let us use this one. What is this? This is p power y to the power x power z equal to a square. We know that p is a to the power x, so I can write in place of p a to the power x y. In place of q, I can replace by a to the power y x z equal to a square. So this is what is this is a to the power xy, a to the power xy z equal to a square. So since the base are same, I can add these two numbers. So in the same, let me erase here. In the next line, this will be only 2 times, and the power will be outside z. Okay. So this one, by the third law of indices, this will be again multiplied by the powers by x, y, z. So this will be what ultimately? This will be, this implies. Okay. So from here, since the base are same, a, so I can write 2x, y, z. So the powers will be same. So I can cancel 2, this is 1. So ultimately this is x, y, z equal to 2. So hence sure. So let's see one more. Proof there is this. So this we start from left hand side. So this one I can break it as BA minus CA XCB minus AB AC minus BC. Since the base are same, so we can add the powers. So x BA minus CA plus CB minus AB plus AC minus BC. So if we check it carefully, this CA AC are same, cancel. BA and AB are same, this cancel. BC CB cancel. That means we are left that x to the power 0. And we know that anything to the power 0 is 1. This is my right hand side. Hence proof.
Stay home, stay safe, do it for yourselves, do it for your family, do it for India. Let's break the chain of COVID-19. Hum honge kamyab. Jai Hind.